Hi everyone, my name is Melanie, like Rebecca introduced me, and I'm going to be presenting today this topic that I'm very excited about actually within Sensing Clues and Nature First. It's really a great addition to as we are finishing up our project and adding, making up the score of all that we've accomplished in these 3 years of the Nature First project. And this is something that we're very happy that we were able to create in the last couple of months, and I'm going to tell you more about it. But we start with a little bit the use case. So who would be interested in this talk really? Well, it's the person who is interested in the conservation status of a landscape. So if you're a park owner or landowner or private landowner or with an NGO trying to protect a natural area and trying to find out what is going on in this area and how this area is developing over time, then this is where you're supposed to be in this talk, because we're going to try to answer some questions such as how to monitor your landscape. So it's really, this is connecting to the biodiversity monitoring part of Nature First. And part of that is landscape and how landscape changes and how the vegetation in the landscape is built up, which is some important parts of how the biodiversity is doing. And so how do you monitor that? How do you, over time, check on the status of your landscape? How do you show the impact of landscape alterations if you're planning to look at implementing something that possibly help the landscape? Does that actually happen? Can you prove it, so to say? Or if maybe damage is being done, you might also want to show the effects and prove them. And how do you compare in your area? So can you see a difference between different types of land uses? Maybe in the forest, a whole different thing is happening than in the cities. So these are some of the questions that we're going to try to answer, hopefully, in this presentation. And that is really, the use case of what we're presenting to you today. And sorry, it's I've put here the map of an area in Zambia, a small area in Zambia, which is kind of has been our sort of a key area that we used, our sort of trial site. And it's what I'm showing you today is a bit fictional, but it's based on one of our field partners at Sensing Clues who are actually looking at this area. But the questions that I'm posing are fictional, is not something that they have necessarily asked, but we're hoping that it will spark some interest by showing you a real-time example. So today's topic, I'm going to start with telling you how this project came to be, which is by volunteers. Then we're going into the use of satellite data and how we can turn that into a time series, an environmental time series. We're going to combine it with land cover data, which I very briefly mentioned in the first questions that I have. A small demonstration of an application that we built for this, so anybody can use these tools that we've developed and we're discussing today. And I don't know if this is in the way. So disclaimer, this presentation contains a lot of maps, sorry, because this session is all about mapping. I'm a mapping specialist, so there's going to be a lot of maps involved. But first off, I want to give a big shout out to our team of volunteers. We collaborated for this project with Correlate. We gave them a challenge because we had a lot of data sitting by, and anybody who works with data knows that you're probably never going to get all of the value out of it because there's so many options, there's so many ways you can use it. So we decided to ask volunteers to help us with this and create more value out of the data that we already had. And that's really, so what you're seeing today was made possible by this team. So big shout out to them. and let's continue. So when we think about satellite data, I guess everybody has a little bit of an idea with it of what it is, and knows that there's probably a lot of satellites in space, especially with all the new programs at the moment. It is in the news, I think, quite regularly. But I first want to ask a question, which is how often do you use satellite data? And I think mainly in the work atmosphere, I want to ask this question. So is it really daily, like me, or weekly, or more on a project basis? So Rebecca has created the poll, and I will quickly see if you can put in your answer just in the Google Meet. I think it should be easy to vote. And then I will have a quick look to see your answers, to see if we have any, how mixed our audience is. Let's see.
Can you see the results, Melanie? They should come up live.
Oh, I think I have to vote too. then I can see. So
I got already 4 votes, but now it's balanced out. So daily, regular, sporadic, and project has each 1 vote at the moment. So please, if you haven't voted yet, go for it.
Yes,
the poll here on the right side.
So the daily is me. I had to vote to be able to see the results. So that will be me. But then it's kind of nice if we have a little bit of everything already.
Can you show the QR code again to do the voting, or is it not a poll like that?
No, it's a Google Meet poll, so it should come up on your screen on the dashboard on the right side. We got 10 votes.
Yes, so right now the most are in project basis, so occasionally, so they have at least some experience with it. Sporadic, then actually I think I forgot to put no. I can say. So I'm gonna say sporadic maybe also is no, that you don't have experience, which is of course also possible. And also quite a few people who regularly use satellite data. Now I know a few people here in the audience that maybe are those regular votes, but still I hope it's going to be an interesting talk, because though we are aiming a little bit for people who don't want to go into too technical details and want to be able to use the value of satellite data in their work, in their reporting, in their projects, we hope to make it easier for you to access this data, to get some valuable insights out of it. But I think it's still really great also if you have GIS experience, to see maybe how we're doing it, maybe give us some feedback. So see it as an exchange. So that's great. Okay, we have a really nice mixed crowd. So I will continue now that I know a little bit who is here with us. Let's see. Yes. So when we say satellite data, I think actually everybody is actually quite familiar with it, even though they don't know, because in Google Maps you might use it frequently when you travel and when you look up your routes. Also, I hope many people here have played around with Google Earth. At least I think for me that was something that during growing up I used that a lot, and maybe a few of you had the same experience. But so satellite imagery, I think, is easily accessible in a way. But to go the next step, that is what we're gonna discuss today, and answer those questions about landscape opportunities that we have with satellite data. Maybe first quickly with about nature first. We use satellite data quite a lot. It has a lot of power. because you can get a wide variety of environmental information, and that is something that, yeah, with our goal of monitoring biodiversity, something we gladly use. So here are a few examples of where we take satellite data, create derivatives, create features that go into some of these outputs that are, for instance, we have our human-wildlife conflict radar, which is an application that we've been working on the past 3 years, trying to give people a heads up about where conflict might occur. And this is largely based on environmental data, on geospatial data, satellite data. And I think what is important to say is that we, in many of these applications, the use of very up-to-date data is important. So in the radar, we want to see how conflict changes, how conflict is predicted right now at this almost real time. So we want the latest and greatest satellite data. So within the project, we've been collecting satellite data to practice and to feed it into our models. But we keep looking often in many of these applications that are shown here at the most recent data, especially when that's when it's highly relevant, like in this real-time app, which is the radar. But and for that purpose, we created a ecosystem base map. And what this is a set of environmental data in which satellite data plays a big part. With these, so we keep these, we call it an ecosystem base map. These are the layers that feed into our models with which we create these products that we hope we can help people in the conservation field. And what is a feature that we have not really looked at so much is the dynamic aspect of this data. So we've been very aware of this aspect, but as I mentioned before, we mainly use the most recent data to update our models and show products that are looking at the now, at the here and now. And in that process, we've been collecting data throughout the last 3 years for our field sites. We're working together with some 4 field sites, areas in Europe where people are trying to assess the conservation status or solve human-wildlife conflict problems, all sorts of things. And for that, we said, well, for these areas, we will collect this data. And so in these 3 years, we've collected quite a lot of data, but we have not really taken full benefit from this temporal aspect. And that's what we called in this project, because we want to use the full range of data. There's a lot of value in the amount of data that we have over 3 years of time that we're not using so much at the moment. So here we're looking at an example of where we're coming back to our example area in Zambia. And you see here a recent time lapse of satellite data. This is just a true color, as we call it, composited. So how we see it from space. There's some cloud cover in there, which we'll touch upon a bit later. But you can see how this area changes quite a bit over this season. It's because it's in the southern hemisphere. In December, it's most lush, most green. We can see a lot of green here. It's drier in August. But this is a little bit how our example area looks over time. And from this, this is a starting point, but we want to get the most value out of this information. And I'll show you quickly in a second how we try to do that. So how to capture the landscape over time is really the first question that we asked ourselves, like, what is the most important thing that we, or the most, the smartest way to start with assessing this satellite data and getting some of these questions answers of how is the health, the status of our landscape at this moment and in previously, going back in time. So that's what I've put here. These are the questions we want to answer. So what is the trend of vegetation in this area, and how does it compare? How does the current situation compare to the status quo? Because I think we all know that landscapes are changing, and we have this hypothesis that they are changing more in the recent times than in the longer history. So can we make this comparison to a sort of and see if there is a status quo? How has the landscape been very stable over in history, or has it been very variable? And another question is if maybe in this area that we're looking at, if some locations are deviating a lot, and maybe it should raise some concern, or positively deviating is also possible, of course. We'll show you examples of this, but these are the questions I just wanted to have mentioned, and then we'll touch upon all of these in the next couple of slides. And just a quick, this is a quick explanation about the sort of parameter that we use when we talk about vegetation, the status of the vegetation, and really talking about the health of the vegetation. So we use this index, which you can derive from satellite data, and it's called the Normalized Difference Vegetation Index. It's okay if you don't know this name or forget it, but it's a very important or very heavily used vegetation indicator, and it also it's a we've been using it in different ways. Also in the previous slide, I showed you some other products. I think NDVI is in all of them, so it's really something that we use very often. So we said if we want to look at landscape conservation status, let's begin with NDVI because it's so commonly used, and we can always later branch out and make more use of the power that satellite data holds. But we start with the NDVI, and I think the most important thing that you should try to get from here is that we have this range in NDVI values from -1 to 1. And when we're closer to 1, we have really healthy or abundant vegetation. So big trees, big forests. That's what's happening close to 1. And then grasslands are a little bit more around this 0.3 point. That's still a good amount of vegetation, but not as abundant as the forest. And then we have more, when it becomes more dry or arid, then we're getting into this like orange range around 0. And anything lower than that is either dead or inanimate. So like water is also shown as a very low value, a minus value. And we use this color scale. It will come back. So from green, healthy vegetation, to brown, which is dry or arid, or just no vegetation at all. So this is really this has been our main focus for trying to get this landscape status to give that a proper label, so to say. So just quickly here showing you what it looks like for our use case or example area in Zambia. This is the NDVI over this area, where we again remember that the bright green is healthy vegetation. So probably here, I hope you can see my arrow. In the right side of the image, we have a lot of forest, it seems, bright green. And scattered over the area, we have probably some more forest or grassland with the lighter green colors. And we also have some quite dry area indicated with the brown colors. Again, we also see a little bit of missing data, which is due to clouds, but that's something we skip over now, and I'll come back to it. And then, just like I showed you the satellite data as the human eye sees it in the beginning, we can also make this time series of the NDVI. So we derived it from that satellite, from those satellite images, and we see here over time that in August there's very little green. So the land is very dry. There's very little in bloom. And all the way going up to December, the area really starts to sparkle green. So we have very lush vegetation at that point in time. So just to give you an idea of how it changes in the visual representation, again, going from this brown to green scale. And that brings us to sort of the first product that we created. And in this project, which was also really important to us, is how to capture the information that is in those images into a very useful chart and something that you can use in your reports when you're discussing this area and want to show some proof of how this area is doing. So we're looking here at actually kind of two elements: the historical data, which in this case is based on Sentinel-2 satellite. It's a type of satellite, and it ranges from 2019 till today. So there's imagery starting from 2019. So when we say historical, it's those amount of years. And then we have the average NDVI over this area in Zambia that we have looked at in this presentation, is in the black dots, and around it is a blue interval which shows the standard deviation, so the boundaries kind of on which the most of the values fall in this area. So it's a relatively narrow boundary, as you can see. And where it becomes really interesting is we then take the current situation and try to compare that. So in the purple, we see the current year, the current year's information of the mean NDVI, that's the average NDVI in our area. And if we plot that next to our historical, then we see how our current year is deviating from the historical sort of bandwidth, we call it, or the status quo, if you will. And so we see in some months, like in February of 2023, this is in the example, there's really a deviation from outside of the bandwidth. So it may have been it's a higher NDVI value. So there may have been it may have been a very lush year, a very wet year, so that the trees could grow, the grass could grow, and it turned out a bit higher than normal. And we see places where, for instance, here at the end in December, where 2023 deviates really, it's negatively deviating. So there's a much lesser NDVI in that year compared to the average of this 2019 till 2000. In this case, we take everything up until 2023. So this gives you some evidence. If I'm a landowner and looking at this, I would say, well, in this year, apparently in December, something must have happened for this deviation to take place. And maybe you already know that it's been a really wet month or a very dry month, but you have some proof now you can show the data, and in actual numbers, and include this in reporting maybe to your funders or stakeholders. So that's the first chart, one of the most important ones, because there's actually, it seems maybe like just a simple chart, but there's a lot of data that went into this. It's because what I maybe have not mentioned yet, this satellite data from Sentinel comes out every 5 days. So we aggregate it here per month, but we have around 5 or 6 maps every month. So, and then over the course of until 2019. So that's a lot of data that's in here. And like we said, trying to really capture this time element in this graph. And then already I'm going to quickly go to our application. So we wanted to not only do some research on how to best capture your landscape status in graphs and figures, but also make it very easily available. So we have a web app where users in control and can make some decisions on what he wants to see. So you can look at the where or when. You might have one project area, you might have multiple project areas. So we can we divide it up into these project areas that are of interest to you, that are sort of one unit. The when is important, so you might be interested in this year because it's very recent, but you could also be interested in previous years and making that comparison of against the history. You could also do that, of course, for another year. So we make that possible. And the level of detail we also included here because it was one of our research questions as well within the project, to see if so this satellite data can come at a very high resolution. So very good level of detail, but do we need it for an application like this where you're mainly interested in this historic abundance? So there's a bit of a trade-off there that I will explore a little bit later, but here you can basically see the options that we give to the user, and then the graph comes out for the choices that you make. Rebecca, can you just quickly give me the time?
It's 4:35, so 25 minutes left.
Thank you. Then another thing that I think is powerful is that you have a visual of the area and of what the data we're talking about. So here you see the NDVI of one specific month across time. So again, it is a time series, but specific to a single month picked out from each year that we have, so that you can see a little bit how this value changes over time. And it's mainly to support the figures that we have, so that you can get a little bit more of understanding. But also something that becomes apparent from here, we have 1 year here, 2020, where there was a lot of cloud cover. So the data that we are looking at, the satellite data we're looking at, is subject to cloud cover. There are data sources that are not, but we chose to go with this data source for now. And so we have this problem of cloud cover, and that, if you know that, then you can take it into account when interpreting the graphs. So that is mainly what this figure is for. And then something we also wanted to put on the map. So because now, so you have this chart, you can put it in your reports about what the deviations over time are. But you might also want to go into the field and inspect some of the locations that are deviating so much. And that is what this map is for. So it's a delta map, we call it, the deviation of NDVI from that mean historic bandwidth that we calculated. And now we're putting it more spatially on the map so that people could be given this map, and the landowner could say, please investigate these areas in the north, because they've been apparently there's been a lot less vegetation this year than in previous years. So maybe we can go inspect that. And there's also areas where it's bright green, where it's improved. So maybe those areas are interesting to show to our funders that we're doing a good job. Maybe if you implemented some measurements, you're hoping to see some improvements here. And with a map like this, you can show it. You can show that currently the status of the vegetation is doing better than previous years. So that's the map element. I think here is important. You can take it with you into the field. So that's another part of the application. You can create this map. I'm going to go to the last big topic, which is land cover. So we have now everything that we looked at before was based on this complete study area in Zambia. So all the statistics are at the moment calculated over this complete area. But we could also be interested in dividing up this area, and one very well-known way is by sort of land cover or land use type. So we're adding an extra dimension here. And so the questions that we're then going to be answering additionally is, what are the trends of specifically the forests in my region, or how do the forests compare to the crops? Is there a difference between how these parts of the landscape react over time? I'm coming back to the bonus later, but first I want to show you. So in the application, this is a separate part where you have this added element of choosing your land cover source. And then at this moment we have the LULC, which is a product by Esri. People with GIS experience hopefully know them, but it means a land use and land cover map. So it's a standard map that is used in geospatial data science, and it gives you the option to choose a particular type of land cover. So here we have, for instance, crops. The larger categories are crops, forest, human-built area, or water. So those kind of distinctions you can make, and then you can compare the output, the same output that we've seen before, the chart of comparing the now versus the status quo, but with this extra element of we're only looking at the areas that are identified as crops. So we can see one small thing I think that is nice to highlight is that where the maximum of the crops is kind of around 0.6 here, that of the forest is closer to 0.7, so it's a bit higher, which is what we would expect maybe as well. And so you can put these next to each other, and maybe you're only interested in crops in your area, or maybe in both, but this gives you a lot more flexibility within an area. And that brings me to the bonus, is that you can select your land cover source. We could put any source of land sort of division into this. So and you could also think of other things than land cover. We could think about, I have a protected area and a non-protected area. So make that comparison. So we're making that possible with this feature, and there's a lot of opportunity to update that. Just for a quick visual, this is how the land use map looks that we've used in this project, and it's just a division of the area, and so the statistics that were in the first chart that I showed created over the whole area are now, for instance, only over the purple area here. So we make it very easy to make distinctions between types of land use. with this. And yeah, like I said, we have this as an example case, but we can subset this with any other type of land division map you have. This is also included in the application to make sure that people understand what they're looking at, again, to support really the chart and give a sort of visual about where also are these trees and crops located in the area. I think I would like to, for now, maybe skip the demonstration, since I would really like to go to the maybe more the discussion part of things. Or what do you think, Rebecca? Shall I maybe have a quick look, or how are we in the time?
It's 43 now.
43. Yeah, I would. Okay, maybe I can very quickly just give a look, but I think most of you. You've seen a lot already in the presentation and the options that you have, but just very quick look that this is an accessible tool that you can just go online and look at this. It's open source because we made it with the volunteers, and here you can see the choices that I've shown you before. So we can now. We've been looking at this case of Zambia, our prototype, but we have some other areas here available, and we can try that out as well. So I'm going to just make a different graph. Well, and then so I make my choices here, and the graph shows up. And so if you're if you're a landowner with multiple areas, you want to split up your area. It's very easy to create the graphs in different ways, and also, like I said, you can have a different reference point if you want. So we can look at the now, but we can also look at last year and make the comparison there. And those options are given to you here. You can create the maps in this part of the app, the time series, and then we have the Land Cover Explorer. Where we have this added division over the land cover type. So we can create the figure here that we've seen before actually in the presentation. So crops, and then you can see here the choices, which depend on the type of source that we use. These are the options that you have at this moment. So this is really, I think, a big also, we were very happy with the volunteers that they were able to do this, able to build an app around this, because usually the research is an important part, but then how to bring the research into the field, into the hands of the people that need it, and make it very easy for them to work with this tool and to get the graphs and maps that they need. That's what we've achieved, I think, with this project. Going back to, I think, how can I? Yes. So the app is live, and I think we can share it later, maybe. But first, let's come back a little bit to the beginning use case. So. We've made an attempt here to answer some of those questions of monitoring a landscape, comparing different types of land cover in your area, looking at deviation, which areas are deviating a lot. I think that with this tool, we provide a lot of opportunities to answer these questions. And of course, there's a lot of possibilities that to add information here. And other models and ways to assess the landscape. So this is really the starting point, I think I would like to say. But it's the start of being able to report on your landscape and maybe even also taking some of these products into the field with you to have a look at the landscape and sort of find some proof in maybe the ideas that you already have, that you know that some areas are getting drier. Well, now you can show it. You can show it on the map or show it in the graph. So that's what we attempted to do with a great team of volunteers. And I would now really like to ask another question. Seeing these elements that I mentioned, which one do you think is most useful? These are the chart, the historic versus current chart, the deviation map, or the land cover explorer, where you have this option of adding zones. So Rebecca, I hope you opened the poll, then I will go back to the presentation and see.
It's open. You're welcome to vote.
Yes. There's also another option if you maybe think either maybe you have another idea of what is the most useful, or if nothing was useful, it's an option too. Just if you want to react, please, you can also unmute yourself. I cannot see the outcome yet. Now I can. Yeah. And actually, I again forgot the option to put all. Well, maybe other can also be all. If you think everything is useful, then I can also put it there. So it's nice to see that there's a lot of votes on the land cover analysis. And I see it's interesting. So it seems like especially the visuals, the map visuals are coming out as the sort of most useful here. Maybe we wait for a few more people to vote, or if somebody wants to react. Okay, I think we keep it here. So, but it's very interesting because I think, yeah, our idea was that the time series chart is very valuable for reporting. Maybe in the audience there are no people who are reporting regularly, or we need to update some things. But that's what the next question is for. Please. Give a review. It would be really great if you could put in the chat just quite shortly, what do you like about what was presented today? So the elements of the application, and maybe also more importantly, what could be improved, or what are you really missing in this application? Because we're hoping to make this a tool for many areas, conservation areas in the world. So any feedback you have, it would be great. This project is relatively recent. We completed it earlier this year, and are very open to keep developing it and keep improving it. So if you could, I would love to see some things in the chat. If you could put a brief message for us. I'm trying to find the chat.
Or if you have comments verbally, you can also unmute yourself. No problem at all.
Yes. Thank you, Spilordes. That's really nice. Nice comment that we make it easy to get to the GIS data. I do hope indeed that's something that we definitely strive for, is to make this data available, especially to non-technical people. So that's great. Thank you. But this, you never know if people are typing a whole story or
Any other comments, maybe inputs, or even questions?
Yeah, definitely. Also, this is a great part for questions if you have them, or if you want me to bring back something, then we can have a look. How to use this for our project area. So I think but we're very open to collaborate. So if you're interested in something like this, then we could definitely collaborate. I think the most challenging part is that you need this this volume of data, right, to create these outputs. It's something you could do yourself. So you we have the application is open source, so you could use it and get satellite data, or you could do it in collaboration with us. We have a lot of experience on how to do this efficiently, and apply it to any. It's also very how do you say, reproducible. So if we have a new area of study, we can quite easily implement that in our code base. It's that's why we also showcase that it's possible to switch between project areas. So it's definitely an opportunity, I would say. The most important factor is that you need this abundance of satellite data. So we have developed that in this project, and we have built that up, so to say, over time. But it's definitely possible to access this yourself or in collaboration with us. So I would invite you to reach out if you're interested. The QGIS, that's great. That's good. So I'm reading now. You are using the QGIS plugins, and so that means I guess you are you are already quite familiar with GIS data and have a lot of experience working with it. So then it makes it maybe for you a bit easier to try your hand at it yourself. But it's really interesting to hear that you're thinking about the same things, and two young faces asking if you could maybe elaborate about your project would be really nice.
And also, I posted the link in the chat for the Sensing-Clues website where you can contact us. You can either send us an email, you can even request a free demo, or you can directly choose an appointment with one of us, and then we can discuss that into detail and also the next steps.
Okay. Is there anybody who has any things that they are missing, that they think, oh, I would really love to see something more, something extra in this application, or especially if you're maybe in the field working on trying to conserve the landscape, or maybe even adapt the landscape, change the landscape. Are there any people here who have some comment to make there, maybe? Okay. I think I guess we'll let it sink in first, and you can always reach out if you have comments about the application, or if you're interested in to know more how it works. Let us know. Yeah, maybe shall I go back to the presentation to finish up? Okay. I see we also in the final minutes. So, Rebecca, will you take over?
Yeah. Shall I share, or do you want to share, Melanie?
Oh, am I not sharing? Sorry. I just thought I was sharing. Yes, I am back.
Oh. Exactly. Yeah, you can go one slide, or maybe, yeah, exactly. Here again, so if you want to have more information, you can either go on the Nature First website or also on the SenseInclude website. And as already mentioned, we offer this environmental time series analysis also as part of the subscription plan with SenseInclude. We can also give you a live demonstration. Just reach out to us either on the website or on LinkedIn, whatever suits you best. And then we will also send you, after the webinar in the next few days, we will send you the slides and the recordings. So you also got all the information together that helps you to make it easier to reach out. And then the last slide for today, if you can go to the next one, Melanie, is about the next event. So there's another webinar coming up on the 12th of June, also with Melanie. It will be on an agent-based model for sturgeons, also a very interesting topic. That will be shortly on the Nature First website as well. And then also coming up in June on the 25th and on the 26th is the Nature First conference. That's a great opportunity to connect live with people and talk about all these interesting topics about conservation and biodiversity, but also forensics. It's going to be in Renen. Is that correct, Melanie? In the
Yes, very good.
in the Owen Hans-Dieren Park, a very nice venue. So yeah, and I think that's it from our side.